Okay, today's goal is to learn how to multiply fractions. So by the end of today, we're hoping to have at least two different strategies. We have a couple here to look at: area model, patterning, the shortcut method for sure, and then maybe another form of area model. So let's just do a quick refresh of some other ways to model fractions. So if we look at something like 2 times 4, and if I highlight this, what I'm interested in when I lay this over is how many of those rectangles have both colors. So in this case, both orange and red. And if you notice, all of them do. And if you count up, there's 1, 2, 3, 4, 5, 6, 7, 8. So this answer here is 1, 2, 3, 4, 5, 6, 7, 8. So we would have an answer of 8, which we know is the answer to 2 times 4. If I come down here and I do a half times 4, and I drag this up and I cover it, and I'm interested in how many rectangles have both colors, both purple and orange. So if we count them up, we have 1, 2, 3, 4. But there's something slightly different about this one. We need to know the size of those pieces. So we have 4 halves, because that little piece right here, this is a half, this is another half, another half, and another half. So 4 halves, if you count those up, 4 halves would be 2. So the answer here would be 2. Okay, so let's try another one. Now we're going to do two fractions with this one, and again, we're interested in where there are two colors. So if we take the purple and we drag it up on top of the yellow, so we can see there are two squares right here and here that have both colors. Now the question is, how big are those? Or what is the size of those pieces? Well, if you look at the total number of squares here, there are 10 little, rectangles. There are 10 little rectangles. So each one of those rectangles is 1/10 in size. So we have 2/10 that share both colors. Now you might see some connections and some patterns here because we've done some other things with equivalent fractions. Keep those to yourself for now. We're going to explore a bit more. Okay, now 3/4 times 2/3. So we're going to do the same thing. We'll drag that up. And we have to count up how many have both colors. Okay, so there's 1, 2, 3, 4, 5, 6. And then what is the size of that piece? Well, if you look, there are 6, 7, 8, 9, 10, 11. There are 12 pieces in total. So each one of those pieces is a 12th. So we would say we have 6/12. Okay, so now if you count them up, there's a whole bunch here. Now I'm going to take those and just rearrange them inside the picture, and I'm going to make it look like this. Okay, so there's my 6/12. Okay, and if you look at this from an equivalent fraction standpoint, we could rewrite that as one giant block and call this 1/2. So if we look here, 6/12 becomes 1/2. And again, you might see some patterns here that you could do this a little faster. That's absolutely okay. We'll get to that near the end. So something we want to use with fractions sometimes are placeholders. So when we have a whole number, okay, we can sometimes put a number underneath it just to make it look like a fraction. So I have a 5 here. So we may find in certain questions writing it 5/1 makes it visually easier to follow. Same thing with 12. We could write this as 12/1. And it doesn't change the magnitude, it just changes the appearance. So if we want to find the product of 10 times a half, so if we were to draw a whole bunch of little circles that represent, and just color in half of them. This is one model you could do. You can always draw pictures, but you will start to notice that they get a little bit time consuming. And if we made this 100 times a half, we would be spending most of the time drawing questions. Okay, so now if we group two together, those two together make 1, those two together make 1, those two together make 1, etc. and etc. Now if we count up all of those, we end up with an answer of 5. Okay, so now in this problem, if we put a placeholder of a 1 there, you might start to see a few shortcuts again. We'll get to that pattern in a minute. So keep looking, it's there. Okay, so patterning from times tables. So 6 times 3, I have a bunch of squares over here, so there would be 6 times 3, and if we count those all up, we would have 18. Okay, so we would have 18 here. If I grab one of these and delete it, okay, that's 6 times 2, and we would go to 12. 6 times 1 is 6. 6 times 0 is 0. Okay, and hopefully we're comfortable with all of those calculations. So now what happens if I bring 6 times a half in there? Well, we know the answer has to be between 0 and 6. Okay, so if I have 6 halves, we could draw that a couple ways. So I'm going to bring this guy over here, and I'm just going to cut them right down the middle. Now if you count this up, there's 1, 2, 3, 4, 5. There's 6 halves. Well, 6 halves is the same as 3. Okay, so let's get rid of that, and then we'll go to the next one, and you'll start to see some connections here, I hope. 6 times 1.5. Well, that means I have one full group of 6 and half a group of 6. Sorry, I'll make sure I draw that right. So now if you look at one full group of 6 and half a group of 6, which we already figured out is 3, then I have a new answer of 9. And does that 9 fit between 6 and 12, which we already determined? Absolutely. Okay, so let's get rid of those, and let's do one more. 6 times 2.5. Well, that means I have two full groups of 6 and 1/2 of a group of 6, which is 3. And if we count those all up, we come up with 15, and 15 fits in between 12 and 18. Okay, so that's just looking at some patterning and how we can break some numbers down. Let's just explore this idea a little bit more. 5/8 times a half. So there's two ways to think about this. We're looking for half of 5/8 or half of each one of the 5/8. So if we look here, this is 5/8 right here. The halfway mark is this line, and if we stack up 1/16 in there, we'll notice that we come up with 5/16 to fill that from the black line up to that halfway mark. If we take half of each one of the 1/8, we would get 1/16 for each one of those, and you'll notice there are 5 of them, so again this is 5/16. Okay, so most of these techniques so far involved drawing pictures, using models, which is a great way to understand, but it isn't always the easiest way to solve a problem. Okay, so here's the shortcut that most people like. If we wanted to find the product of 5/8 times 1/2, and we've seen this a little bit already with equivalent fractions, if I multiply across the top and the bottom, I get 5/16, which is what the answer was in the previous model. Okay, and if we backtrack a little bit and see if that model works, let's go back to here. If I multiplied it straight across the top, 3 times 2 is 6, 4 times 3 is 12, we'd get the same numbers we found in this model. Okay, let's check these ones out. These ones are a little trickier because they're in a mixed format, and we'll talk about that as we get close to the end, but that shortcut will still work. So here's the shortcut. When multiplying fractions, I'll put that in a big red box, it's really important. When multiplying fractions, not in mixed form, so we're going to avoid that for now, you can multiply across the numerators and across the denominators to find the product. Okay, so top times top, bottom times bottom. So if you had 3/4 times 2/5, you would multiply across the top and get 6. You would multiply across the bottom and get 20, and then you could do any kind of lowest terms you want to change its appearance. Okay, so let's try a couple, make sure we've got this. So 1/2 times 12. Okay, so I'm going to put a placeholder of a 1 in here so I can see they're both fractions. I'm going to multiply across the top and get 12. I'm going to multiply across the bottom and get 2. So I'm left with 12/2, and if we reduce that, that is the same as 6. And if you think about it, what's 1/2 of 12? Well, it's 6. Okay, so 3/4 of 12, again, I'm going to put the 1 in there as a placeholder. If I multiply across the top, it's 36. If I multiply across the bottom, it's 4. And then I just have to do some division and reduce, and I end up with 9. Okay, last one for this column. we are going to do, let's change to purple, 5/6. Again, I'm going to put my placeholder in. 5 times 12 is 60. 6 times 1 is 6. If I do that division, I end up with 10. Okay, so when you're doing whole numbers times fractions, putting that placeholder in makes it a little easier to follow. So let's try a few more over on this side. 1/2 times 3/4. So if I make this a 0 and I make this a 1, and I just want to show what a model or a picture of this can be very quickly. This is 3/4. And if I want half of it is right there. Okay, so if we multiply across the top, I get 3. And if I multiply across the denominators in the bottom, I get 8. And so if you look here, I'm going to put a little tick. If you count these up, I'm going to change my number line so it has 8s in it. If we count now, 1, 2, there's 3 8s. So there's another way of checking your work. Okay, let's do the last one here. 3/4 times 3/4. So again, here's 3/4, and halfway would be somewhere in here, but I want to be about 3/4 of it. So let's multiply across the top and get 9/16. So I have to chop up this number line a little bit more. Right now it's in quarters. Now it's in eighths. Now it's in sixteenths. And so I would be 9/16 over 1, 2, 3, 4, 5, 6, 7, 8, 9, which would be right there. Okay, so what if there's a mixed fraction? Well, we'll do this with two methods. One, we can use an area model. It works really well, actually. So 6 times 3.5. You'll notice I break the fraction up into the 3.5, or the fraction piece. So now 6 times 3, that's 18. And then 6 times 1/2, or what's half of 6? That's 3. Add the two together, and we get an answer of 21. Okay, now we can also do this with improper fractions, and there's a nice quick way to do this as well. We do have to know how to change this mixed number into an improper fraction. So the shortcut was 2 times 3, so we're going to multiply this piece and add this piece. So this becomes 6 times, now 2 times 3 is 6, plus 1 more is 7, 7 over 2. Okay, and then I'm going to put the placeholder in for the 1, so there's the 6. This 3.5 becomes 7 over 2. If I multiply across the top, I get a 42. Multiply across the bottom, I get a 2. And 42 divided by 2 is 21, which is the same answer we got up there. Okay, so what you'll find is most people that I've sort of watched over the years eventually end up doing this model. Okay, it's kind of quick, but it does require you to have pretty good multiplication facts. It's not to say it's the only way to do it, it's just what most people tend to move towards because it's a little speedier. Okay, so area model with mixed numbers. What if we have two mixed numbers? So 2 3/4 times 1 1/2. So there's my 2 3/4 on the top, 1 1/2. There are elements of this method that are quick, and there are elements that are a little bit slower. 1 times 2 is 2. 1 times 3/4 is 3/4. So that line was pretty straightforward. Half of 2 is 1. And now the last piece is half of 3/4. And that becomes 3/8. Okay, so I'm going to do something here. I'm going to make my life a little easier. I'm going to convert this 3/4 into 6/8. So now I have 8s in both of these two. So when I go to add up all of my pieces, it works out really nicely. So I have 2 plus 1. So my first part is a 3. Okay, and then I'm going to have 6/8 plus 3/8. So this one and this one added together gives me 9/8. Now 9/8 is an improper fraction. That means I've fulfilled my full block of 8. So this becomes 3 plus 1 and 1/8, or 4 and 1/8, which would be the correct answer. Okay, now we can do this again with improper. It's going to be oops, got to go back there. It'll have a few little challenges in it, but I think we can handle all of those. So let's try it. Make sure we got enough room here. So we are starting with 2 3/4 times, not adding. Come on, where's my eraser? There it is. Times 1 1/2. Okay, so if we convert these to improper, 4 times 2 is 8, plus 3 more is 11/4 is the first term, and then 1 1/2 is, oops, not 7, 3/2. Must be late at night when I'm making this. 3/2. Okay, so now if we do the shortcut where we multiply across the top, multiply across the bottom, we end up with 33/8. Okay, and this is the disadvantage of this model, is that you can get some large numbers. So if your multiplication facts are a little bit reduced, then this can be a little bit more challenging. So now how many 8s fit inside a 33? Well, if you count on your fingers, 8, 16, 24, 32. So I have 4 full blocks of 8 that fit in there with 1 left over, and you'll notice I get the exact same answer as I did up here. So that's 2 ways to approach the same problem. You have to find what works for you. So you have a multiplying fractions task, so thanks for tuning in.